We thought of taking a look at Box's MCP server using Appsecco's MCP Client Proxy tool. We started following the instruction on Box's developer portal and creating an OAuth 2 app required for authentication based on the developer documentation. As our tool uses the same config format as Claude Desktop, we can simply reuse that. Let's run our MCP Client Proxy alongside Burp to attempt to capture traffic from the MCP server. Select 4 for Box MCP. It takes a few seconds to start up. Okay, let's call a tool. We'll do the basic box whoami tool call. If you notice, we're able to capture the STDIO traffic between client and MCP server without any hiccups, right? However, if you notice, no SSL TLS traffic was captured in Burp, although you can see the response come back from the MCP server, right, coming from Box's APIs, and you can see that in the tool also. But the actual HTTP API call to Box's API servers was not captured in Burp. You will face this issue when you're pentesting MCP servers. Most MCP servers will be written in Node or Python using npx or uuvX for execution. Based on the language, you'll have to pass additional arguments in your command line to start the MCP server. Here's an example that works for uuvX based MCP servers. We are passing additional arguments like native TLS, allowing secure host, right, and environment variables directly to UV so that you can force traffic to Burp, right? Using the tool, you'll still be able to capture STDIO traffic as well as get UV to send traffic to Burp. Now let's rerun the tool. And this time we can use no proxy chains because we're using environment variables. That's another command line switch in the tool itself. We'll call a tool. This time we'll call again whoami. You'll notice again STDIO traffic captured in Burp. And using these command line arguments, theoretically, the rest of the traffic should have been captured in Burp. However, you'll notice there are certificate errors. Even though we've configured UV, the command line arguments for UV, to force it to select our security, our SSL TLS certificate stored on the system in which Burp certificate resides. Even then, we see certificate errors. Now, specifically, we see a missing authority key identifier error. We should theoretically have been able to capture Box's MCP server traffic with this additional configuration. However, I learned this today that getting traffic into Burp for applications that are written in Python version 3.13 and above, which is what our Box's MCP server is, there are some additional security controls that have been added when it comes to SSL TLS certificates within this version of Python, making interception Burp a little difficult. We've emailed PortSwigger, letting them know that we've seen this behavior and to see if they plan on releasing any workarounds and fixes to be able to allow capture of traffic in Burp. We'll post an update once we hear back from them. But you will encounter this problem in your pen testing as well, where you have MCP servers that are running with Python 3.13 and above. But you should still be able to capture STDIO traffic as usual within your Burp using the tooling that we have. But for now, because of the SSL TLS certificate issue, we are unable to capture the traffic in Burp.